Hey guys, so in this next section we're going to learn how to apply this concept of a complex number, okay, what we've been dealing with the last couple of days, to what we already know about solving quadratic equations, okay, and we're going to be doing specifically two methods of solving today. We're going to be doing the square root method, which we've touched on a little bit in class, okay, but we're going to see some examples of those in the videos here, and then also the quadratic formula. Okay, we're not going to do any factoring today. We'll be bringing that up again here towards the end of the unit, okay? But we are going to be using complex numbers, okay, in each of our equations here, and so I'll show you what that looks like. Just a couple of things before we get started on the examples, and this is just to help you out when you start working through these problems on your own. If the equation does not have a b term, so if there's not an x term, okay, or a linear term in the equation, the easiest thing to do is going to be to isolate the variable, and the variable in that case is going to be an x squared, okay, so isolate the x squared, and then take the square root of both sides. That's what we call the square root method. Okay, and then the other kind of equations you'll see here are equations that contain trinomials. If you see a trinomial today or on your assignment over this section, you're going to set it equal to 0, and you're going to use the quadratic formula. I've set up all of your equations today so that they are not factorable. Okay, so just to give you a hint, if it's a trinomial, you won't be able to factor it. The only thing you can do is use the quadratic formula. Okay, so let's go ahead and jump into these, starting with example 1. Really quick, notice your directions say find all solutions to each quadratic equation. Okay, it doesn't say all real solutions, it says all. So there will be several times here, in fact, every single problem, that you get imaginary solutions for these. And so that's what we're going to be focusing on here, how to write your answers as imaginary solutions. So for number 1, we have 2x squared plus 32 equals 0. In this case, there is no middle term because b is equal to 0. So I'm going to use the square roots method to solve this equation here. And I'm going to do that by solving for x squared. So that means subtract 32 from both sides, which gives me 2x squared equals negative 32. And dividing both sides by 2, which gives me x squared equals negative 16. Okay, now before this week you would have told me that this is a no solution because, again, there's no number that you can square to get a negative 16. Okay, but now that we know a little bit about complex numbers, we know that there's no real number you can square to get negative 16. There is, however, an imaginary number. So we're going to solve this just like normal. Take the square root of both sides. You get x equals the square root of negative 16. Okay, we know now how to simplify a radical like this. Okay, to simplify a radical negative 16, we need to pull out a radical of negative 1 and make that radical negative 1 times radical 16. That just becomes I times 4, or 4i. Okay. The one other thing you need to remember is, and this is going to be something you need to recall from last year a little bit, anytime you take the square root of both sides of an equation, you have to include your plus or minus sign. Okay, so technically this solution, there are two of them. It's positive 4i and negative 4i, or plus or minus 4i would be your two imaginary solutions to this equation. Okay, for number 2, we're going to do the same thing because in this case, again, b is equal to 0. So I'm going to isolate x squared, which is going to be just one step right here, subtract 15 from both sides. So I get x squared equals negative 15. And now I will take the square root of both sides. Okay, and that's going to give me x equals, I'm not going to forget my plus or minus sign, plus or minus the square root of negative 15. I'm going to split up into square root of negative 1 times square root of 15. You can't simplify radical 15 anymore, so this just becomes I radical 15. Okay, so my answer for this one is just going to be plus or minus I radical 15. Okay, moving on to number 3. This time I have a trinomial. 2x squared minus 3x plus 5 equals 0. Now, if I just gave you this problem sporadically on a quiz or a test, you would probably want to try and see if this factors, okay? It'd be up to you. But you could try sliding the 2 over and you'd get x squared minus 3x plus 10, but you wouldn't be able to think of any factors of 10 that combine to get negative 3. Okay, there are none that exist. So this would be one that you'd have to do the quadratic formula on anyway. I'm telling you today that all of your trinomials you're going to have to do quadratic formula on just to save you some time. But on a quiz or a test, if I didn't tell you what method to use, this might be one where you could try for a few seconds to factor it, and then hopefully you'd quickly realize it doesn't factor, and then you'd go to quadratic formula. So we'll go ahead and start out with our quad formula here. We're already set equal to 0, so we're going to go ahead and just say x equals negative b, which would be positive 3, plus or minus the square root of b squared would be 3 squared minus 4 times a, which is 2, times c, which is 5. All divided by 2 times a, and that's going to give us 2 times 2. Okay, so this becomes 3 plus or minus the square root of 9, and then you have a negative 4 times 2 times 5, which is going to give us negative 40. All over 4, which gives us 3 plus or minus the square root of 9 minus 40 is negative 31 all over 4. Now, before today, you would have just told me this is a no solution, okay? And you would have been correct, but again, now we know that that phrase no solution really means no real solution. And now that we know about complex numbers, we can keep going and we can actually give an imaginary solution for this, okay? So we're going to look at that square root of negative 31, and we're going to think, how do we simplify the square root of negative 31? Okay, well, the first thing I know is I need to pull out a radical negative 1. And so this is going to become I radical 31. And then radical 31 is as simplified as we can make it. 31 is prime, so we can't pull out any perfect squares. So that means that I can rewrite my answer as 3 plus or minus I radical 31 all over 4. I talked about this a little bit in the last video. You're going to see these problems probably written, the final answers, in 2 different ways. This right here is perfectly acceptable as your final answer, as long as it's reduced, okay? The other way you might see your answer written is as 2 split fractions. So you might see it written as 3/4 plus or minus I radical 31 all over 4, and that would be perfectly acceptable as well. Okay, let's go ahead and take a look at number 2 now. So or number 4, I'm sorry. So for this one, we have x squared minus 4x plus 5. Again, if this were on a quiz or a test, you might try to factor this, but the only factors of positive 5 are 1 and 5, and those don't add to get 4 here, so you're going to have to do quadratic formula on this anyway. So you get x equals negative b, which is going to be positive 4, plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a is 1, times c, which is 5, all over 2 times, again, a is 1. This becomes 4 plus or minus the square root of negative 4 squared is 16, and then you have negative 4 times 1 times 5, which is minus 20, all over 2. And that becomes 4 plus or minus the square root of negative 4 all over 2. Okay, same thing we did in the last problem. We're going to simplify the radical first. Well, the square root of 4 is just 2, so that means that the square root of negative 4 is going to be simply 2i. Okay, anytime you've got a negative underneath your radical, hopefully you figured out by now that you're just going to have an I in your answer. Everything else is going to be exactly the same as when you have a positive. So this becomes 4 plus or minus 2i all over 2. And now we can reduce a little bit on here because we have a 4, a 2, and a 2 that we can all divide by 2. So when I cancel these out, I end up getting 2 plus or minus I all over 1, or just 2 plus or minus I for my answer. Okay, a couple more. Here's number 5. We have 3x squared plus 46 equals 10. This is a quadratic that does not have a linear term. B is equal to 0. So this might be one where it's easiest to do the square root method and solve for x squared. I'm going to give you a chance to try this on your own, so go ahead and click pause. Look back at 1 and 2 if you need to figure out the steps for this one. And then once you think you have an answer, click play to check it, please. Okay, let's see how you did on this one. So to solve for x squared, you need to subtract 46 from both sides and then divide by 3. So you end up getting x squared equals negative 12. Then you can take the square root of both sides, and so the square root of negative 12 would simplify to 2i radical 3, and you can see my work right here for that. So that means x would be equal to plus or minus 2i radical 3. And then finally, number 6, we have a trinomial again. 3x squared minus x plus 2 equals 0. So you're going to need to use quad formula on this one. Again, why don't you click pause, try this one on your own, and then once you think you have an answer, click play to check and see how you did. Okay, so for this last one here, you're going to set up your quadratic formula like this: positive 1 plus or minus square root of negative 1 squared minus 4 times 3 times 2 all over 2 times 3. So you end up getting a radical negative 23 down here in this step. That simplifies to I radical 23. And so your final answer, your two zeros, would be 1 plus or minus I radical 23 all over 6. Okay, just like for the last few videos, if there's anything on this that you just at all don't understand or need a refresher on, please shoot me an email with those questions so I can be prepared to address those the next time I see you. Feel free to rewatch anything that you need to. And until I see you next time, have a nice day. You're all wonderful people. Take care.